So let me discuss something advanced. So what we are going to discuss in this session. So let me talk about that. So I have shown you this zero order construct. So it is one of the zero order construct, and zero order construct is the construct which is not which cannot be measured directly. The zero order constructs are those constructs which cannot be measured directly. They can be measured with the help of items, and all the items are represented in the rectangles. So you know that construct item is the variable or the statement which is used to measure the construct, and all the numbers are known as construct loadings. We calculated the validity of a zero order construct by estimating the composite liability and average variance extracted, and R squared some. Okay, so these are multivariate normality. These are the assumptions of zero order construct. And yeah, regarding the minimum number of items in a construct, you must be very clear that if you are using the structural equation modeling in MOS, it is required that minimum 3 items should be there in the construct. However, if you are using the PLS, only 1 item is required. Even single item construct are sufficient in PLS. So there is a difference between PLS and MOS with respect to the minimum number of items in a construct. In MOS it is 3, and in PLS it is 1. Then now, after analyzing the zero order construct, we have to analyze the first order construct. The first order construct means when we combine 5 zero order construct. In this diagram, you can see that I combined 5 zero order construct and examine the reliability and validity of the construct. So this all the construct taken together is known as measurement scale, and the purpose of designing this measurement scale is to represent the structure of the scale. So we here we can say that there are 5 constructs in the scale, and all the 5 items are measured by different statements, right? And after that, we examine the convergent validity and the discriminant validity by using the. We also use Fornell-Langer criteria. A multivariate assumption of normality is also required. Sample size in case of MOS, the sample size is at least 10 times as compared to number of variables. For example, if you are having 25 variables in a model, you must have the sample size of 250. However, in case of smart PLS, you count the number of items in the largest construct. Suppose in this case, the customer support service is the largest construct, having 5 items. So 5 multiplied by 10, 50. So only 50 sample size is required in case of smart PLS. And statistical model fitness we examined in MOS as well as PLS. And in MOS, there is a rule of parameter called 1. So according to this rule, every construct must have 1 item having the parameter of 1. So you can see that in the first construct, you can see 1 in first item. There is 1 item which is having the parameter of 1. So we are following this rule. And now I'm discussing on the second order construct. So there is second order CFA. So I'm showing you the 3 examples of second order CFA. This is example number 1. In this case, the brand employer branding is known as second order construct. The second order construct is consisting of 3 order construct like corporate reputation, organization culture, and HRM policies. Now the question is that when we should go for second order construct. Like for example, if you examine the first order CFA of these 3, like I'm telling you, suppose we are doing this, right? This is called first order CFA. We are not including this, only we are running this model, and we found that These three correlations are very high. It means the discriminant validity is not there, or we can say the multi-collinearity problem exists in the three. So in simple language, I can say that when discriminant validity not applicable in the first order, then you can show the validity by choosing the second order option. So this is the concept of second order CFA. And second order CFA is quite popular in literature. It is very, in most of the cases, I found that the second order is applicable. Like, for example, I can tell you, if you are, if somebody belong to the organization behavior, there is a concept called emotional intelligence. Now, the emotional intelligence is consisting of personal intelligence and social intelligence. Then personal intelligence further consists of three things: self-respect, self-awareness, and self-realization. And the social intelligence is also measured by social skills and social interaction. So this is a second order construct. So there are many cases when the construct is of second order. So like in this case, employer branding is a second order construct, and when one construct consisting of three zero order construct, so then this construct is known as second order construct. And you can examine the validity of a second order construct by doing only the convergent validity. Discriminant validity is not applicable on second order construct, right? And but you will go to second order construct when there is a problem of high multicollinearity in the zero order construct. So this is the problem when you should move from first order to second order. You have to check the statistical fitness. Rule of parameter one also work here. Rule of parameter one means when you are joining the three zero order construct to the first order construct, there must be at least one parameter in one of the item. One of the construct, you must have the parameter of one, right? So this is called rule of parameter one. And in case you are having only two construct in second order construct, both the parameters should have one. So these are the rules of handling second order construct. Similarly, in another example, I'm showing you what happens when you are having a combination. Okay, so this is another example of second order construct like adverse quotient. Recently, everybody was talking about adversary quotient. Adversary quotient means when the things are against you, how to take the intelligent decisions, right, in those scenarios. So I know that everybody is suffering from some adverse scenarios. The most important point is that how you're taking decisions in the adverse scenarios. Are you suffering from the depression or you are taking the wise decisions? So that is adversity quotient. Adversity quotient consists of 5 zero order construct. So this is also one of the example of second order construct. Now, in this case, you know that I am having the combination of second order construct. Like CR is a second order construct which is consisting of three zero order construct, BL, BV, and PI. Similarly, BADD is a second order construct consisting of BSC and BP. And SQ is again second order construct. So now I'm having the combination of second order construct. So this is the case of second order mixed CFA. Second order mixed CFA. So we have to check the convergent as well as discrete validity of this kind of CFA. And in this case, the multicollinearity is expected in the first orders. So that's why we are moving to the second order CFA. Okay. So similarly, we are having the second order SEM. I'm telling you that some of the examples which are examples of second order. Like here, you can see that the OC, organization commitment. Organization commitment is having a significant impact on OCB. Here, OC stands for organization commitment and OCB stands for organization citizenship behavior. So here we are examining the relationship between two second order constructs. So whenever you are having a different second order construct, you can examine the relationship between them using the SEM also. So this is structural equation modeling is called second order SEM. And then I'm telling you another example. In this example, we want to analyze the personal intelligence on the sales performance. Here, personal intelligence is one of the construct in emotional intelligence. So as I said you that emotional intelligence consisting of two aspects, personal intelligence and social intelligence. So here personal intelligence is measured by self-awareness, self-regulation and self-motivation, and we want to see the different component of personal intelligence on the sales performance. Basically this is one of the project where we examine the impact of personal intelligence of the sales people on their sales performance. So this is another example of second higher order SEM. Okay, so let me show you one by one that how can we perform all these things in MOS, and few things I also want to show you. Let me see this slide. SEM. Okay, fine. So now I am showing you one by one. First of all, I will show you the second order CFA, and then I will show you the first order SEM, then second order SEM. Then I will discuss some of the points in mediation and moderation. Okay, so let me move to the MOS, and we'll discuss one by one. Share screen, and I am sharing the screen. This is the MOS. Okay. We observed in this scale that all these are highly correlated. FA, FB, FC, FD are highly correlated. If you remember, I have shown you this. MSV is very high. The AVE is lower than MSV. So when you have this condition that AVE is lower than MSV, it means there is a problem of discriminant validity. In that case, if theory support, we can go to the second order CFA. So now I am showing you the second order CFA, how to do that. So first of all, I have to remove all these circles. There are no circles, second order arrows, double-sided arrows. Okay, so let me take it here. Okay, so this is a second order construct. So I should write here. The name is second order and construct. So whenever you are making the second order construct, you should check it should be supported by the theory. Otherwise, randomly we cannot make it. This theory should support second order construct. I am just telling you the process of examining the process of testing the convergent validity. Okay, so now this is the connection. One thing you can see, all the arrows are emerging from the second order construct and they are joining the first order construct, right? After that, I have to follow the rule of one. In rule of one, I can click on any one construct and assign the parameter of one. So this is the rule of parameter one. You can see that. So whenever you are making the second order construct, one item, one zero order construct must have the parameter of one. The second rule is that whenever you join the arrow, tip of the arrow, so wherever you are joining the tip of the arrow, you have to connect those with the error term. So error terms comes everywhere whenever you are having the tip of the arrow in MOS. So this is another rule, and now I can run it, and I can show you the process of calculating the discriminant validity. Convergent validity. After that, you may know whether it is a valid construct or it is not a valid construct. So this diagram is known as second order construct. And let me go to the plugin. Name to all the circles, and इसको भी second कर देते हैं. Second. Yeah. So now I'm running it. Yeah, software is running it. and we have to check the results in the output. So this is the view text. Here we will get the output, and the output is here. Yeah, so you can see the output. Now in output you can see all the values are very high, more than 0.7. So that's why we adopted this second order construct. Now we have to check the validity of this construct. So let me copy these values in Excel, because we have to do it manually. I am taking the help of the Excel in calculating the validity of this construct, and I'm opening a new workbook. Okay, so we are having the 5 beta. So let me copy in the second here. So we are having all the beta here. So these values are known as construct loadings, and I am showing you how to check the validity of this construct, whether this construct is a valid construct or not. Okay, so first of all, I will calculate the square of the beta. So it is beta square. Beta square, you know how to calculate. This is beta, and you do the power and 2. So this is the beta square, and after that I will calculate the error term. Error is equal to 1 minus beta square. 1 minus beta square is the error term. So now we are having three things: beta, beta square, and the error term. And from this we can calculate the composite liability and the average variance extracted. Okay, fine. And this is basically, this is the construct loading, we call it beta. Now you will take the sum of the all the three things. So let's take the sum of beta, and similarly we take the sum of all the three. This is sum of the beta square, and this is sum of the error term. And from these three terms we can calculate the three values. One is called convergent validity, and second is called AVE, composite liability, and AVE. I'm telling you the formula of it. So I'm writing the formula for composite liability. This is equal to sigma of beta square upon sigma beta square plus sum of the error term. Similarly, I will calculate also average variance extracted, which is the summation of beta square plus summation of the error term. So this term is common in both the formulae, but you can see we are taking this square of the sum. Here we are taking the sum of the square. A square of the sum and sum of the square is the only difference, and basically this is the sum of the beta, this is the sum of the beta square, and this is the sum of the error term. So from this I can calculate all the formulas. So let me calculate the CR first, which should be more than 0.7. CR is equal to sum of the beta square. This is sum of the beta, and let me do the square of it. Sum of the beta square divided by and sum of the beta square, this term square plus sum of the error term. Now you can see that the composite liability is very high. Actually, it is CR should be greater than 0.7. It is required, but it should not be greater than 0.7. So 0.9. This is a problem. CR more than 0.9 is actually a problem. It is not very good. So we cannot say it is very good. AVE, let's calculate AVE, which should be greater than 0.5. AVE equal to the sum of the square divided by this plus this. So I'm just applying the formula. Okay. Now you can see that these two values we calculated from here, and the problem, because as a statistician I know that these are the problematic figures. These are not the right figures. And what is the problem I'm telling you? Okay, so CR is 0.97 and AV is greater than 0.86 here. So what is the problem? Problem is that this CR value should be greater than 0.7 but should be less than 0.9. AVE should be greater than 0.5 but should be less than 0.8. So these two conditions we have to fulfill in case of second order construct, and these if these conditions are fulfilled, then you can go with second order construct in the structural equation model, right? So if you want to apply this second order construct in a structural equation model, these two conditions should be fulfilled, otherwise you will face a lot of problem in a structural equation model too. Okay, so this is my second order construct, and I hope something is going into your head, because I know that I normally take 6 days workshop of conducting all these things, but today I am little bit fast. Okay, so let me delete it. Yeah, so I have examined the validity of a second order construct. So now I am showing you the what happens when you are having the mix of second order construct. So let me tell you that also. I have to find out CFA. Yeah. So in this case, I hope you can see the MOS file. Yes, you can see. And in this case, I have the mix of second order construct. Here CR is second order construct, BAT is also second order construct, and SQSC is also a second order construct. Okay, so now I'm showing you how to test the validity of this. We just check whether the data is attached or not. Yeah, file is already attached, and the data name is second order mix CFA. So everything is ready, and I am running it. After that, you are having the results here in the output, and once more we will do check the validity of this. Go to estimate, and so these are the results. So I am showing, copy these results and paste in the validity master. So this is the file which we downloaded from the Professor Juskinson website, and second order standardized regression weight we paste here, and similarly I will paste the correlation table. Yeah, you can see this correlation table, and let's paste it here and do the analysis. Now you can see that yeah, there is a even problem of average variance. Now we are having a problem of convergent validity. So we are having the problem of reliability, and we are having the problem of convergent validity. So these two problems we have in the data set. And actually, I'm telling you, the problem is a journey of the researcher. Many times you can see all the value red, which makes tension in your head. But don't worry, we are having the solution of each and everything. Uh, the only thing is required is that you should be aware of a method of collecting the data, how to collect the data, because at that stage you can, if you can remove all of these problems. Okay, so now the point is that I showed you how to check the validity of a second order construct, first order construct, and the mix of second order construct. Now I am going to the application of the construct in the structural equation model. So let's move to the this. Okay, so I have to open the CFA. Let's go to the new part. But the only problem is that if I do this, it will take more time. So I don't want to make the diagram. Open the CFA which I make in the previous lecture. That was on the desktop. Desktop, no, ये save नहीं हुआ शायद. No issues. So now I'm showing you the structural equation model, and the first model which I'm going to show you is this. Not so. This is the model which you can see. It is a first order SEM. So I will show you the first order SEM first. Then I will show you the second order SEM, and then I will show you the mediation and moderation applications. So this is my first order SEM, and I am going to show you how to make it the diagram and how to examine the diagram. So let me open the blank file. So this is an entirely blank file, and I go to the view, interface properties, because I want a landscape page. So I click on the landscape legal page. So now as a result, you can see this landscape page where I can make the diagram very easily. But before that, I have to attach the file, data file. The data file is I have in the workshop folder, and let me click on the file, training data, training. Yeah. So data is there. So because data is there, so variables I can see easily. And from these variables, now we are going to make the diagram, SEM diagram. So we have the diagram like this. I have a practice, so I will take less time in making the diagram also. So this is my endogenous construct, and this is my mediating construct, and these three are my uh, exogenous construct. So I have 5 constructs in this. So let me do some beautification so that you can see the diagram very clearly. Yeah. Now I want to join the arrows. So these are the 4 hypotheses actually which I want to test using the structural equation model. And I told you that all the hypotheses should come from the theory. You are not allowed to do the data mining or model mining kind of things. And I know that one of the professors scolded me very heavily once in one presentation because all the hypotheses are not supported by the theory. And then the rule 2 is one of the rule is that you have to join all the independent construct by the arrows so that you can capture any correlation between the exogenous construct, and then you have to find out that which construct are having these arrows. So you have to put the error term here. This is another rule, and my diagram is complete, so I can run it. And but before that, I have to send the variables. So variables I can send here, like this is AS1, AS2, AS3. So this is the construct number 1, and this is construct number 2. BS4, BS5. This is construct number 2. Similarly, we are having the construct number 3. And now this is construct number 5. Okay. Now, because these are sentences are big sentences, so I want to reduce to the item code. Yeah, now you can see the item code, not the big sentence. And we are going to complete the diagram. Okay. So we have sent it the all the items in the items. Then we go to the plugin because we have to give the name of the circles. And if we click on the name unobserved variables, you can see this option carefully. Name unobserved variables. We have all these circles filled, but the naming should be proper. So this is management sincerity, MS, and this is selection criteria. So I put rights SC, and this is CS means training quality, and this is employee improvement. So I should put E, employee improvement, and this last is the organization productivity, OP. So this SAM is called first order SAM, and I want to check which relationship is significant and which relationship is not significant. So let's run it. Before running, the software asks me for save. I'm saving this on the desktop. SAM first order, and now I can run it. Yeah, after running, you can see this red button highlighted. Let's click on the red button. So you can see all the values. So let me show you these values clearly, so that you can see that what is this meaning. Okay. Now this is 0.93, seems to be highly significant, but frankly speaking, any value, any beta more than 0.8 is risky actually. So I don't feel 0.9 is very good. 0.9, actually in social science, prediction cannot be so accurate. That is actually the problem. And this problem we are having because the data is full of biasness, and when your data is biased, you will get all these kind of problems. So this 0.93 and 0.94 is not a very good sign. Okay, so we can check the hypothesis in the by running it. Let's run it once again and go to the output. In output, go to the estimate. Okay, so we can see that these two relationships are not significant and two relationships are significant. So out of the four, two relationships are not significant and two are significant. Why they are not significant? Because the p-value is more than 0.05. So the impact of MS, management sincerity, on employee improvement is not significant. The impact of selection criteria on employment improvement is not significant, and only the two relationship are found to be significant, TQ and EI. So training quality is having significant impact on the employee improvement, and the employee improvement is further having a significant impact on the OP. So this kind of result we are getting, and then I have to show you the model fitness. Model fitness, this is slightly high, where this is poor, this is poor, this is also poor, and so RMSE is also poor. So my goodness of fit indices are not supporting my model, so I cannot move with the help of with this model, right? Because model fitness, you can see that C min upon DF should be less than 0.05 it should be less than 5, but it is not less than 5. GFI should be more than 0.8, it is less than 0.8. CFI should be greater than 0.9, it is less than 0.9 here. TLI and NFI, RFI should be greater than 0.9, but they are less than 0.9 here. And last figure is RMSEA, which should be less than 0.05, but here you can see it is more than 0.05. So no indices support my model. All the indices are poor, and I cannot present this kind of model in front of any panelist or in front of any in any paper. Then I have to check the normality also. I have to click for normality. I have to click the this is the test for normality and outlier. This is important, and ideally normal distribution is very important in SAM, and you can see that this value 390, this value is known as Mardia coefficient of kurtosis. Actually this value is expected to be less than 50. Then we can say the model is fit, otherwise the model will have some problem. And here one of the problem we can see is that the Mardia coefficient of kurtosis is very high, it means multivariate normality is not there. So because of the lack of multivariate normality, I cannot present this model. I cannot use SAM in this. So I am showing you the same problem, same model in PLS, because in AMOS, because of the lack of multivariate normality, I am not getting the goodness of it. So let me check this same model in Smart PLS. So let me okay. So what is the process in Smart PLS? I am showing you from the scratch. So we are having the data in AMOS training data. So hello, Haji ma'am, yeah, नहीं वो लग गया होगा. Okay, am I audible? I just want to check because I just got the phone from somebody. Am I audible? And have you seen the slide? Is everything fine? So if yes, kindly say yes in the chat box. Hello? Yeah. Okay. So एक बार पूछना जरूरी होता है कहीं सारे सो तो नहीं गए. Thank you. So let me continue. Okay, so now I'm showing you the steps in PLS. So this is my data, and first of all, if you want to apply PLS, then you have to convert the data in CSV format. So this is my data, and I have to save this data in CSV format. So I'm saving on the desktop, and the name of the data is training data, and I am saving as comma delimited CSV. So this is the first step if you want to use PLS. Now the data is in desktop, and I can pick this data from desktop very easily. So let me open a new project, and I am showing you from the scratch training project for workshop. Okay, now okay. Then software will create a new project for you. So first of all, we have to import the data. You can see here. Let's import the data first, and we are having the data in the desktop. This is my data. Okay. So after that, you can see the data. Number of missing observation, mean, medians, everything is there. And I will click on the project. This is a blank project, and I want to create a project, SAM project in PLS. So the same, you can see the indicators variables here, and I am making the model. So making the model in PLS is more easier than AMOS. So now you can see that I am having all the variables, and this is a dependent variable. So take it to the right side. This is my mediating variable. So take it at bottom. Yeah. And all these are my exogenous. So connect them. So I'm connecting the independent variables to the mediator first, and then I will connect to the endogenous. Right. So after that, my model is complete. So this is a SAM model, but this SAM model is based on PLS. And you can apply the PLS model only when you are having the either the formative construct with you or less sample size with you, right? Or the model is very big. So now I'm showing you how to check the hypothesis testing in PLS. First of all, you click on calculate, and you can see there there's an option called confirmatory tetrad analysis. This confirmatory tetrad analysis I was telling you, this will check whether your constructs are formative or reflective. Like, so if we click on this, we can examine whether all the constructs are formative or all the constructs are reflective. So, and you can do the machine learning with the help of blindfolding and PLS also. This process will divide the data into two parts and make the model in one part and predict on the for the second part. So moderation effect you can do with the multi-group analysis, and validity you can check with the help of consistent PLS algorithm. So my objective is to check this SEM, so I will go for bootstrapping. Let me give the name of the construct first, otherwise in output we are not able to identify that which variable is this. So latent variable 4, latent variable कौन सा click हो गया, latent variable 4. Okay, let me right click on it, go to select, right click, rename. This was management sincerity, and rename management sincerity. Okay, now this was selection criteria. Okay, and this was training quality. Okay, and this was the employee improvement done, and this was the organization productivity. So we have defined all the variables here. Now just do the calculate and go to bootstrapping. So number of bootstrapping is 500. Basic bootstrapping we are doing, and we are doing bias corrected bootstrapping. Start. Now click on the start calculation and you will get the result. So software is showing you that two hypotheses are significant, and in these two null hypotheses cannot be rejected. In first and fourth, the null hypothesis can be rejected, can be rejected. In hypothesis number 2 and 3, the null hypothesis cannot be rejected. So this is the result we are getting the PLS. Almost we are getting the same result as we got in the AMOS, but here we are safe because the problem of multicollinearity is not discussed, and the problem of multivariate normality is not a problem here. Even if your data is not having the condition of multivariate normality, you can go to the PLS. Now, if you see the model, all the values you can see here, and I can change the model to some extent. Representation of the model is very good in here, and I want to see for inner model path coefficient and p values. Now I have path coefficient and p values. Similarly, for outer model, I want to see path coefficient and t values, outer weight loadings and p values. So now all the values are become p values, and we want to use this. So bold arrow representing the significant impact, and the not bold is representing the less impact or no impact. So two arrows you can see here are bold, so we have significant impact on this, and two are not bold. Okay, and so this is the process of testing structural equation modeling in AMOS and PLS. Okay, after doing this, now we are moving to the higher order SAM and PLS. Higher order SAM. So you must know how to adjust the higher order SAM in the data. Okay. So today I will not ask that whether you are with me or not, because I know that you are not with me, and I am little fast just because I want to show you the facility that you have in the softwares, right? Because knowing all these things is important. rather than I discuss only one thing in detail, that strategy will not work today. So I'm showing you most of the facilities that you can do in MOS and PLS. Okay, so now I'm going to the second order SEM. Let me show you the diagram of second order SEM first, so that we can make in the uh, MOS. So this is an example. I hope you can see this example. Let me check whether you are, yeah, I shared this screen. So this is one of the example of second order SEM. In this example, this OC is the second order construct, and OCB is also the second order construct. And now we want to run it with the help of the data. So there are three rules of second order construct. Number one, all the arrows should emerge from second order and move to the first order. This is the rule number one. The rule number two, okay, let me show you in the whiteboard what are the three rules of second order construct. So I call it three rules of second order construct, and the second order SAM is basically the application of uh, this part. So this is a second order construct, and you are applying, you are using in a SAM. So there are three rules. So whenever you want to introduce second order construct, rule number one is that the direction of arrow should be like this. The direction of the direction. So you check the direction of the arrows. Direction of the arrows. Right. It is from second order to first order. It emerges from second order and move to the first order. Then rule number two. Rule number two is that one of the parameter is one. So one of the parameter is one. Rule number two. Rule number three, that all the first zero order construct must have error term. So this rule is of the error term. Error term means you are having the error term. So this is the E1, E2, E3. Right. So there are three rules of second order construct in SAM. Right. So you must have clarity on this. So I repeat once again. First rule is the direction of the arrow. Second rule is the parameter of one. And the third rule is the rule of the error term. So these three rules you have to check. So I just telling you this is second order, first order, and first order. The direction of the arrow is like this. Parameter one means in any of the arrow you can fix parameter of one. Rule of error term means you have to join the error term on the zero order. So these are the three rules, and now you can use these three rules in second order SAM. Okay, so now I'm showing you the second order SAM. Let me check the model first. I'm going to share one of the file. Yeah. So in this file, actually, we are working nowadays. This is a project, and it is one of the paper in which I am working. So let me show you the concept here. This is the model which is explaining the entrepreneurial activity. This is EI. EI stand for entrepreneurial intention. E is a entrepreneurial awareness, and PER is personality something. And we are having these constructs, define all the constructs from the theory, and this is the model we designed according to the theory, because theory I would not like to discuss at this time because it will take a lot of time. And now what is the main thing which I want to show you here? This PER is a second order construct. This EA is a second order construct. And uh, you can see the one here which is following the rule number 2. The arrow of the construct is rule number 1, which is from the first order, second order to the zero order, second order to the zero order. The direction, rule number 2 is 1. You have to put 1, like in this case I put 1 here. And EA is also a second order construct, and I am putting 1 here. And then I will put arrow on the first order construct. All the rules are fulfilled. And now I want to check the SEM. So let me check whether the data is there or not. So I have to put the data. And after attaching the data, I can only apply. Okay. So now the data is there. If we run it, we can see the results. Yeah. So you can see that all the results are coming here. This is 0.76, it is 0.16, and we have to check the standardized estimates. Yeah. After analyzing all the estimate, we have to check the output. If we click on the output, we can see the output. And output is here. So the probability value is telling you that all the relationships are significant. Almost all the relationships are significant. 2 relationships are not significant here. And so according to these p-values, the null hypothesis cannot be rejected. Sorry, null hypothesis can be rejected. Because the null hypothesis can be rejected, it means there is a significant relationship between the different constructs. So the pair of the construct you can see here. For example, if we want to see the impact of PER on the EA, the p-value is telling you that there is a significant positive impact. Why positive? Because it is positive. There is a significant positive impact of PER on the entrepreneurial alertness. Okay, and then we have to check the model fitness, and because model fitness is one of the important thing. This C mean upon DF, you can see it is less than 5. Very good. And then you have to check the GFI, AGFI, CFI, and all other things. So let me show you one by one what we have to check here. Although I explained previously in previous lecture also. So C mean upon DF should be less than 5, and GFI and AGFI should be greater than 0.8, and CFI should be greater than 0.9. TLI and this RFI, NFI, this NFI is slightly less than the TLI. So these two values should be greater than 0.8, and TLI and CFI should be greater than 0.9. And finally, we have to check one more value, which is known as RMSEA. So RMSEA, you can see it is yeah. So here we are having the value called RMSEA, root mean square errors approximation. This value should be less than 0.08. So these are, if these criteria are fulfilled, and your hypotheses are coming from the theory, and you are taking decision on the basis of the p-value, it means after that you can report your result in the paper. And the normality should also be checked here, and you can see that my normality is 145, which is not very high. Ideally it should be less than 100 or 50, but 145 is not a big problem. And second thing, you have to check whether all the critical ratios are less than 1.96 or not. If all the critical ratios are less than 1.96, it means your data is normal, near to the normal. But we are having many values here more than 1.96, so some problem is there in the normality. If we don't have these problem of normality, this value 145 should be less than 100 or 50. Okay, so this is the second order construct we can do in SEM and in MOS. So this is example of second order SEM. I hope now you have some clarity on the second order SEM. Okay, now sometime I want to give on the mediation and moderation part, because in structural equation modeling, mediation and moderation is very common. So let me speak something on mediation and moderation. Recent projects, advanced PPT, mediation. So first of all, let's talk about the mediation, and then I will talk about the moderation. So mediation effect. Actually, when the construct is coming between the two, like here you can see that M is coming between the X and Y. So X is affecting Y through the mediating part, mediating variable. So there are two type of effects we have in mediation. One is called direct effect. This is the direct effect, directly X on Y. This is called direct effect. And there is another effect called X. Okay, let me see whether you can see these slides or not. I hope I shared. No, I don't share this slide. Let me check it whether you can see it or not. Yeah, now you can see the mediation part. So I'm telling you the mediation. In this case, this X is affecting the M, then M is affecting the Y, and X is also affecting the Y. So this is called mediation. And in mediation, we are having two effects: the effect on X on Y and the effect of X on M on Y. So these two effects we can see in the mediation, and the effect of X to M on Y is called indirect effect, and the effect of X on Y is called direct effect. So we have the both effects in mediation, and if indirect effect is significant, it means the mediating effect is significant. And there are different kind of mediation effect. The basic type is full effect and partial effect. The full effect of mediation happens when direct effect is insignificant. When in the presence of mediating effect, significant indirect effect, the direct effect is also significant, this mediation is called partial mediation. So we have okay, so we can check the mediation. We are having these kind of mediation: partial mediation, full mediation, serial mediation, and parallel mediation. So first of all, let me explain partial mediation, full mediation once again. When your indirect effect is significant but direct effect is not significant, so this case is known as full mediation effect. And when partial significant indirect effect is there but direct effect is also significant, this case is known as full mediation, partial mediation, sorry. Now I'm showing you some of the methods which we are using to test the mediation. Mediation can be examined with the help of Barron-Kenny method, and the Sobel test is also there for testing the mediation. Then we have bootstrap test to check the mediation test, and nowadays process package is popular, very popular for examining the mediation and moderation. This is a Barron and Kenny method where we examine the total effect, direct effect, and indirect effect. And if total effect is significant, then we will go to the indirect effect, and when indirect effect is significant, then we go to the direct effect. Okay, this is a Sobel test, and the Sobel test is having this formula. The Sobel test is used to check whether the mediation is there or not. So Sobel test is the most old test which is still relevant to some extent, but the problem with Sobel test is that it requires the normally distributed data. If your data is normally distributed, you can go for Sobel test. If your data is not normally distributed, then you can go for bootstrap test. So this is the test next step, which is called bootstrap test. And bootstrap test is applicable when your data is not normal and you have to test the mediation. After that, this is the table which is reported in the mediation in research papers. And now I'm telling you some advanced type of mediation which is very common nowadays. The one test is known as serial mediation. In serial mediation, there are two mediating variables. Like in this case, you can see that this is first mediating variable and this is second mediating variable. Now X, the independent variable, is affecting the dependent variable through these mediating variables. So actually, because the two mediating variables comes in the serial, first, second, and this effect is also significant. Means the second mediating variable is also affected by first mediating variable. So this mediating concept, when one mediating is affected by second mediating in the diagram, this is called serial mediation test. Serial mediation test. And serial mediation test we can do with the help of process software, and it is very easy test. We can apply process software for testing the serial mediation. Then we go for a parallel mediation. So this example is the example for parallel mediation. Uh, you can see that there are different mediating variables in parallel. This is one first mediating variable. This is second mediating variable. This is third mediating variable. So you are testing three mediating variable at a time in the model. So this mediation is called parallel mediation. And after that, let me show you the moderation effects. Okay, let me see. I'm sharing this slide or not. Yeah. Moderation effect. So let's discuss on something on moderation effect also. Yeah. So moderation effect means when the relationship between X and Y is different for male and different for female. So that is called moderation effect. The recent example I can tell you that when I was in IMT, all the policies are different for Bengalis and non-Bengalis. So treatment of Bengalis and non-Bengalis are entirely different. So this is called moderation effect. This is the moderation effect of caste, right? So when the relationship between X and Y are different for different people, different gender, different age groups, different caste. So this is known as moderation effect. Moderation effect, right? There are two types of moderation effect. One is the categorical moderation effect, and one is called continuous moderation effect. So let me show you the both. So this is the simple moderation, and in this moderation, the X is my independent variable, Y is my dependent variable, and M is the moderating variable. Moderating variable, right? And there are two types of moderations. One moderation is called categorical moderation, and second kind of moderation is called continuous moderation or interaction moderation effect. So here you can see in this diagram, there is a separate diagram of B1. B1 is category 1 and B2 is category 2. So in both the categories are different between X and Y. Here we are having one independent variable, one moderator variable, and we are finding the effect of the product of interaction variable on the outcome variable. Okay, let me show you like this. So this is a linear moderation. Uh, this is X1 is the independent variable, M is the moderating variable, and what we do, we multiply X with M. So we want to see whether the product of X and M is having the effect on Y or not. So if this beta 3 is found to be significant, then this moderation effect is known as conditional effect or interaction effect. Similarly, in PLS, we are having this product indicator approach, which is quite popular in in this PLS. Okay. So these are the different examples of moderation effect. Group moderation effect is also the moderating effect. Now I am telling you some new concept जो आपने सोचा भी सुना भी नहीं होगा अभी. ये भी आपको हम दिखा देते हैं. There are two combination of mediation and moderation also, right? Nowadays people are talking about the combination of mediation and moderation. So there are two type of combination of mediation and moderation. These are known as moderated mediation and mediated moderation. So let me show you the concept of mediated moderation and moderated mediation. अब देखिए, now in this case, X is having the effect on M. M is the effect on M is the having effect on Y, and X is the effect on Y also. Now we want to check whether the impact of X on M is different for different categories. If the impact of X on M is different for different categories, if yes, it is known as moderated mediation. It is called moderated mediation. And in this case, you can see that we are multiplying the independent variable and the moderate variable. So this is the multiply hai beech mein. This multiply is indicating that we are taking the product. We are assuming that the product of independent variable and the moderating variable is having the effect on mediating and the outcome variable. So here X into M. X is the independent variable, M is the moderating variable, and we want to check its impact on mediating variable and mediating variable on the outcome variable. This concept is known as mediated moderation. So we are having these advanced concepts also, which are very popular, and we are combining moderation and mediation. So I'm telling you some of the examples of both. So this is the paper which is talking about the combination of mediated moderation and moderated mediation. And yeah, so I'm telling you some of the examples for moderated mediation. In this diagram, you can see that X is having the effect on M, mediating variable. Mediating variable is having the effect on Y, and X is having the effect on Y. So the moderator variable Z, we are testing only for the path A. So if this beta of moderating variable is significant, it means path A is different for different kind of people. ये जो X का M पे effect है, the effect of X on M is different for different kind of people. So this is called moderated mediation. So we are having different possibilities of moderated mediation. I'm showing you like okay. Now let's see process model 7. Actually, in process software, the model number 7 is talking about the moderated effect in moderated mediation in case of path A. Similarly, in model number 8, you can see that we are testing the moderation effect of W between the path A and the path C. So if we are test, we can also test the effect of moderating effect in path A and path B. So this is also example of moderated mediation, and we are having different possibilities of moderated mediation. This is now in this case we are testing the moderation effect in the path B. Here we are testing the moderation effect in the path W. Here we are testing the moderation effect on the path B and C. So these are the different possibilities of moderation, and even these are the different cases. So now see this model number 59. In model number 59, we are examining the effect of all the path A, path B, path C. We simply want to check whether all the relationship are different for different categories or not. So for example, in most of the cases, we find out whether the effect of X on M, M on Y, and X on Y. This is different for male as compared to female. Is this different for AP assistant professor as compared to professor? Is the path different for let's say the young people and middle-aged people? So when we examine this mediating effect on the different moderating variables, this concept is known as moderated mediation. Okay, so this is another example. Yeah, it is a famous example that when you take rum and it will have an impact on the anxiety, and anxiety will have an impact on the depression. And this relationship is significantly different between the people of high perceived control and the lower perceived control, right? So you can imagine that when you, after taking rum, your anxiety level will come down, and this relationship is different for different kind of people. So this is called moderated mediation effect. Although actually it is not rum, actually it is some rumination. Rum, I'm telling you for just uh, make the topic light. Okay. Mm, so this is the moderated mediation. Yeah, these are the steps which can be done in process to apply moderated mediation. These are the different steps I noted down, and all these steps are there for examining the moderated mediation and all. So uh, in structural equation modeling, I am showing you one more important property of the process. So we are having the MOS, we are having the PLS, and we are having a process also. I'm showing you the process now. This is my SPSS software, and in this SPSS software, if you go to the analyze, if you go to the regression, and you can see this process. This is a package provided by Andrew Hayes, and if you click on it, you can check all the mediating effect, moderating effect in few minutes. Right. Only requirement is that you must know how to deal with process software. I conducted a 5 days workshop only on mediation and moderation in the starting of this month. So where we discussed almost at least 15 type of mediation and moderation effects. So process software is very important software for examining the moderation and mediation effects. And uh, in most of the papers, I have seen that they even uh, no, mention that we calculated the moderating and mediating effects using the process. So you can apply the this package very easily. So you have to define what is my dependent variable, what is my independent variable, and what is my mediating variable, and what is my moderating variable. Just random I'm doing, and you must know what is the name of the model. Suppose I know that my model number 21 is mediating moderation. If I click on that, now you will get the result in few minutes, right? So you will get the results very soon. The software will give you the results of mediating moderation, moderated mediation, and all kind of mediation and moderation, like serial mediation, parallel mediation, like this. Okay. After that, I am showing you the moderation effect in PLS software just for demonstration. Suppose this is a model, and I want to check whether this model is different for male and female. So I have how to do this test. I'm showing you. So first of all, I should go to the data and generate group. Let me check whether the gender is there is not or not in this data. Gender, gender, hai, gender hai. So I have the gender variable here, and here the first value I give to the males, and second value I defined for the females. Second value I defined for the females. And after declaring the variables, you can directly go to the model, go to calculate. You can see this option called multi-group analysis. So in multi-group analysis, you can do the moderation effect very easily. I am comparing the male and females together and do it, and you will get the results within 1 minute. Okay, so all the p-values are more than 0.05. It means the male and female have similar behavior in the model. Means the model is this model is similar for male. This model is similar for female. So there is no significant moderation effect of gender on the for relationship between in the model. So these are the relationship on which we are testing the moderation effect, and the results indicate that all the moderation effect are insignificant. Now I'm showing you the interaction effect, which can also be done here. Suppose in this case, this is the model. Rest of the things I should delete, otherwise it will create a problem. Okay, now in this case I want to test the moderation effect of ms. Ms is my dependent variable, training quality is my moderating variable. So you can see I click on this and go for add moderating effect. Now I'm telling you the software that my moderating variable is training quality and independent variable is management sincerity. Just click OK. So this is the moderating variable, you can see, and I want to saw the indicators. So now you can see the indicator is ms multiplied by tq. So this is a moderating variable I added in PLS, and just run it, do the bootstrapping. And yeah, so I have to check whether this moderating variable is significant or not. Yeah, so you can see that the moderating effect is significant on this because p-value is highly significant. So I can say that there is a significant effect of moderating effect of training quality, assuming the management sincerity as the independent variable and employee improvement. It means if training quality varies, because it is a moderating variable, the impact will be different, right? If the training quality is different, then the effect on the employee improvement also different. So we can identify the moderating effect like this. It is just a few minute game in PLS, and after that I'm showing you one more thing. So we can examine the moderating effect like this. So let me delete it. Now we back to the model. Now I am showing you the confirmatory tetrad analysis, which can also be done in 1 minute. And in tetrad analysis, I'm just telling you how to decide whether the construct is a formative construct or the reflective construct. Now you can see that all the constructs are here. This is the training quality, and you can do for employee improvement, management sincerity. Like first, let's check the training quality. In training quality, count the p-values. How many are significant? So in this case, you can see that this is insignificant, this is insignificant, this is insignificant, this is insignificant. So all the p-values you can see are insignificant. If majority of the p-values are insignificant, it means this construct is a reflective construct, because we are accepting the null hypothesis that the construct is a reflecting construct. So it is one of the most popular technique available in SEM, PLSM, where you can identify whether the technique is a moderating, whether the construct is a moderating effect, whether the construct is a formative effect. So like if I click on the organization productivity, here 3 are found to be significant, 2 are found to be insignificant. So even if you consider this construct as a formative construct, you will get the result. So the statistics is showing you that this construct is actually a formative construct. It is not a reflective construct, right? So we can identify with the help of tetrad analysis which construct is a formative construct and which construct is a reflective construct. For example, in this case, if I see the results, I should consider this construct as a formative construct. So let me go back to his, and I want to convert this construct in a formative construct. So you just right click here, and you can click on this switch between formative and reflective. So now you can see that the arrow is emerging from the items and they are connecting the constructs. So now I converted this construct from a reflective construct to a formative construct. Now, if I run the bootstrapping again, I will get the better results as compared to previous. Okay, so it's still two results are significant, two are insignificant. So let me see the model. Yeah, so you can see that this is a much better model as compared to my previous model. So you can decide all these things by the softwares. The only thing is that you must be aware of each and everything. So I know that I covered almost most of the topics which we discussed in the workshop, and so telling you more things is much better in SAM, because nowadays everybody is talking about SAM, but they don't know what we can do in the SAM. And I missed some topics also, like I did not cover path analysis in SAM, and I did not cover some more topics also, like interaction effect, how to make the diagrams and all. But I suggest you to attend some specialized workshops on Amazon SAM, Amazon PLS, so that you will understand each and everything in detail. Okay. So one of my workshop is also going to start from 1st July on specialized PLS and SAM. So now I'm going to take queries. Only 8 minutes are left. So let me take some queries. And
One question. Thank you for a nice session, sir. One question is that, sir, can we apply SEM to primary data only?
SEM is applied only with the primary data, not to the secondary data.
Another question, sir. Manjunatha, she has asked that, can you please suggest a nice book or material for SEM?
I posted my all the books, actually all the books in my Facebook page. They can download from there.
Okay, sir. Sir, another question is that how we can improve the goodness of fit?
By improving the normality of the variables, and because first condition is that all the variables should be normal, and our second step is that your CR value should be between 0.7 and 0.9, and if you manage all these things, then yeah, the third point is that the two constructs should not have high correlation between them. So if you manage three things, then goodness of it automatically comes higher.
Okay, sir. One which is a better software for SEM than MOS, sir? This is asked by Rooprekha Bakshi.
Actually, the MOS is one of the best software for SAM, but we have to move to PLS in some special cases. For example, if our data is not normal, if the number of sample size is very low, and if we are having the formative construct, and if we are having the mix of formative and reflective construct, or sometimes what happens that we are having only single item construct. So when we are having these cases, then we can go for the PLS. Otherwise, MOS is the best software.
Okay, sir. Another question, like, I'm getting a lot of compliments for the session, at the same time that the session was overloaded with information and very fast. But besides that, sir, मेरे को और कोई question दिख नहीं रहा जो
Actually, I decided to this lecture in this way only, because I have two options. One, I discuss only few topics, one topic in detail. But actually, SAM is not a topic. SAM is actually a book. You can't teach one book in 2 sessions. So that's why knowingly I decided to teach you all each and everything what you can do in SAM. So even if the benefit of this session is that now you heard about moderated mediation, now you heard about mediated moderation, now you know that categorical moderation, interaction moderation, mediation, serial mediation, parallel mediation, right? So I told you so many things. At least you are aware about these things, right? So if you are aware about all these things, you know the ways to learn all these things. So I designed my lecture in such a way that I can tell you most of the concepts in SAM rather than teaching you only one single concept.
Sir, a question is there that is the project that you are discussing is with value collected on scale or with mean standard deviation, sir?
No, I am doing all the actually I am applying all the models on the 7 point scale mostly. Most of the cases 7 point and 5 point. I don't like to apply SEM on 5 point scale because there is a lot of problem comes in 5 point scale. In 7 point scale because we are having a lot of variations, so the all the goodness of it and validity comes very fast.
Sir, that is there. Even the same, when we were discussing with the resource person, same question was being asked, and even non-parametric test, when we were doing it on Saturday, same suggestion was being made again, that instead of having a 5 point scale, it is always better to have a more extended scale, so that comparatively it is easy to have better results in case of a primary data if we are collecting, sir.
Yeah, yeah, definitely. Actually, this is true.
So that way, sir, in a way, we are all endorsing the same point of view, sir.
Yes.
Okay. I don't find, sir, any more questions, like all is there. Dr. Amir, you find any other question that is unanswered? Sir, one is a question by Amrit Jyoti Lekharu, that UT AUT model, sir. अगर एक बारी आप थोड़ा सा repeat कर देते, sir.
Actually, I can explain you UAT model. Basically, whenever a new technology comes, we want to study that how this technology is adopted by the people. For example, after demonetization, you know that e-wallet is becoming very popular. So we can identify that what are the different parameters which is affecting the intention to use of this technology, and we can have different independent variables like performance, expectancy, social norms, enjoyment. So right, so these factors are affecting the intention to use, and intention to use may affect on the intention to continue it. So whenever you want to analyze the adoption behavior of the consumer for a technology, then you should go for a UAT model.
Okay. So there's a question by Dr. Shifali Rai. She is requesting that if you can explain the bootstrapping uses once.
Actually, when we are having the sample size, lower sample size, so we are having an option of bootstrapping. Bootstrapping is something like, if, suppose you are having a bag. If you are having a bag, in that bag there are 50 balls. So if you pick 10 balls randomly, noted their values, keep it back, then again pick 10 balls randomly, noted their values, and if you continue to do this thousand of times, so basically, you will have a lot of data uh, after this process. So whatever data you are having after this process, if you apply any of the technique, that is called bootstrapping.
Okay. Thank you, sir. No more questions. Only a lot of compliments are there. I can even assure the participants that even I personally went to the Facebook, visited the Facebook page of sir, and a lot of wonderful information and videos are there. Even without attending the workshop, I could just look at some of the videos, which is very nice, sir. There's a one last question, sir. We'll take up. It is by Divneet. She's asking that when going for structural model, latent variables should be included or path model is better, sir?
No, construct is always better. Path model we apply in a very rare cases.
Huh.
Always SEM is much better.
Sir, there is a question by Dr. Sonal Gupta from Hansraj College, that how to improve validity and how to remove biasness in it, sir.
Actually, you cannot remove the biases because it is in the data. Only thing is that if you know this concept, you have to take care during the data collection procedure only. Right, if we know the concept of biasness, so whenever we collect the data, we should keep in our mind that biasness should not be there. Once you get the biasness in the data, it is very difficult to remove.
Okay. Thank you, sir. Just a request that when you will be sharing this PPT or somewhere or in the chat box, I have already shared the Facebook link for once, but
all
lot
the
of participants.
PPTs are already there in the Facebook page,
Yes, sir.
so that is not a problem.
Sir,
Anybody can go and download.
sir, please, if I just request if you can put the Facebook link once more in the chat box, it will be easy
Okay.
for many.
No, I'm sharing the Facebook link, and all the PPTs are there, so that is not a problem. All the
I
PPTs and dataset are already there.
I
Now
request participants
I'm
note
sharing.
it somewhere. We already did it, sir, but sometimes it gets missed by some.
Yeah, now I'm going to share. Just give me 1 minute. So I'm sharing in the chat box, right?
Yes, sir, please, sir. It is a request, sir.
So I shared, and
Thank you,
anybody
sir.
can get the
Thank you,
link
sir.
there. Yeah.
We shared it on the Telegram and all that one, so I just thought that when lot of requests are coming, we can do it, sir, one more time, sir. Thank you, sir,
Okay.
for sharing
Thank
the
you.
link. Now, it is my privilege to propose a vote of thanks after the completion of this session. Thank you to respected Dr. Ajay Kumar Chauhan, sir, for such an interactive and hands-on, and we can say exhaustive session on SEM. Sir has planned the session and made it a point that all the 2 hours are worth listening to him, and we should have a lot of information to absorb. I personally was amazed with his concept clarity, and definitely we must compliment him with the way in which he tried to include all the participants and carry out the learning process for the participants with great effectiveness. Sir has explained in detail the SEM with all possible ways in which it can be done using the different softwares. I also thank him for sharing his Facebook link once here before also, so that the teaching fraternity, which is a part of this faculty development program, can have a better access to their research problems by taking full benefit of his videos and PPT. Commendable contribution being made by sir to solve the problems of the researchers, which we know that as a researcher everybody faces. Thank you, sir. Thank you for being a part of this faculty development program.
Thank
Thank you,
you.
sir. I also would like to thank my other colleagues present here, Dr. Purushottam Kumar Arya, Mr. Amir, for being there for the technical support. And thank you, Ajay sir, once more. Thank you.
Thanks.
With this, we come to the conclusion of the sessions today. I request Dr. Purushottam to end it. Thank you, sir.
Thanks.